Just as the easiest kind of multiplication with polynomials is multiplying a polynomial by a monomial, the easiest kind of factoring is factoring out a common monomial factor. What do we mean by this? Suppose we want to factor the polynomial 3x squared minus 2xy. So we'd like to write this as a product of simpler polynomials. What we notice looking at this is that x appears in both terms. What does that tell us? That tells us that this polynomial is divisible by x. Divisible? Yeah, I really mean divide. We can divide this by the monomial x. What do we get? What times x gives us 3x squared? X times 3x gives us 3x squared. What times x gives us negative 2xy? Negative 2y times x gives us negative 2xy. What does that mean? That means that our original polynomial is equal to x multiplied by 3x minus 2y. And now looking at these terms, we see that they have nothing left in common. 3 and 2 are both prime numbers, so even that doesn't give us anything. How do we describe this situation? We say that x is a common monomial factor of the terms of the original polynomial. And in going from this expression to this expression, we say we have factored out the common factor x. Now, ultimately, we're going to want to factor out all common factors from a given polynomial. Suppose we want to factor out all common factors from this polynomial. Well, let's see. I see that x appears as a factor in each term. And furthermore, I see that although x to the first appears as a factor here and higher powers appear here, well, what's the highest power of x I'm going to be able to divide by? Right. The highest power of x I'll be able to divide all three terms by is going to be just x to the first. So I'm going to go ahead and divide that out. If you can already see what the quotient is going to be, you can skip writing out this step. Because what's going to happen to each of these terms? They're each going to have one less power of x in them. So thus far I have x times 24x squared y squared minus 18x to the fourth plus 30xy to the seventh. Now I also see that every term has a y in it. And I think that I can divide every term by y squared, but I couldn't divide this term by y to the fourth. And I certainly couldn't divide either term by y to the seventh. So I think that next I want to divide my remaining polynomial by y squared. So I'll have 24x squared times y squared gives me this term. Negative 18y squared times y squared gives me this term. And positive 30x squared y to the fifth times y squared gives me this term. This x doesn't disappear. I've now factored out an x and factored out a y squared. My factored form is now xy squared 24x squared minus 18y squared plus 30x squared y to the fifth. All right, so now I notice this term doesn't have any y's in it. This term doesn't have any x's in it. So there's no way I could divide by anything with an x or a y. There aren't any other variables around. But now I notice each of these numbers is divisible by a common number, in this case 6. So I'm going to divide what remains of my polynomial by the perfectly good monomial that is just the number 6. All right, so the variable part here will be x squared. What times 6 is 24? 4 times 6 is 24. This will still be negative since this is a positive 6. The variable part will still be y squared. What times 6 is 18? 3 times 6 is 18. And then the variable part here will still be x squared y to the 5th. What times 6 gives me 30? 5 times 6 gives me 30. So my factored form now is 6xy squared times 4x squared minus 3y squared plus 5x squared y to the 5th. Now, something is going to be occurring to you right about now, and that is that it would be a heck of a lot easier to have just divided by 6xy squared right away. We could have done that, right? We started out with this polynomial. If we'd just divided by 6xy squared, well, we would have said, what times 6 gives me 24? That'll be 4. What times x gives me x cubed? That'll be x squared. What times y squared gives me y squared? I don't need anything more there. What times 6 gives me 18? 3. What times x gives me x? Don't need anything there. What times y squared gives me y to the 4th? Y squared. What times 6 gives me 30? That's 5. What times x gives me x cubed? That's x squared. What times y squared gives me y to the 7th? That's y to the 5th. And I would have gotten the same factored form. And now notice again that these have nothing in common. That is, nothing common to all three. So there are no further common factors we can pull out. We say, in this case, that 6xy squared is the greatest common factor of this polynomial, or technically of the terms of this polynomial. And the process that we see here is factoring out the greatest common factor. Because mathematicians are lazy, we will often write this as GCF. In a future video, we'll talk about how we find the greatest common factor. But for the moment, I'm going to have you practice factoring one out. The greatest common factor of this polynomial is 8x cubed. Factor it out and give your answer as a factored form of the polynomial. Pause the video and try this now. All right, what we really need to do is divide by this thing we think is our greatest common factor. And so we'll ask ourselves, what times 8x cubed gives us 8x to the 5th? Well, it's just x squared. What times 8 gives us negative 56? It must be negative 7. What times x squared gives us x to the 4th? It's x to the 1st. And then what do we need to multiply by to get a y? There are no y's here, so we'll need to multiply by y. Last term. What times 8 gives us 32? 4 times 8 is 32. What times x cubed gives us x cubed? Well, we don't need any more x's, but we don't have any y's now, so we'll need a y squared. So the factored form that results from factoring this out is 8 x cubed times x squared minus 7xy plus 4y squared.